Hello friends, welcome back to the bench. Thank you very much for joining me. Our patient is a motherboard, what is it, MSI? Where's the model? Why do I not see the model? It doesn't really matter. It's an AM5 socket, which has been treated very poorly. I mean, you know how it happens. There. It looks, I think it just, the CPU dropped on it. It kind of looks like something, yeah, definitely there's an indentation here. Now the problem with this one is that, take a look at this outline. It's horrible. So these lines are not touching here, and these little pegs go over the line and here. So this will be relatively difficult to align, but at least on AM5 you have so much room around the socket because those heat sinks are so big. On Intel, the V-core is here, right, close to the socket, like this, which makes it difficult, especially when the electrolytic cups are here. It makes it difficult to put the foil on top of it to protect the rest of the board. But with AM5s, there's no issues because we have a lot of room. So let's preheat it. Let's get the machine going, and let's replace the socket real quick. This is for Isaac. Is an active military member in Japan, or deployed in Japan. So this came all the way from Japan, and that's where we gotta send it back. I was hoping it would came with the return label. That way I don't have to charge anything, because no, we don't charge active military members. If you're in military, then you get free services from this shop, at least at the moment. Because if I get the whole army getting services from me, then probably I will have to start charging something. Maybe I'll just introduce some discount or something. But at the moment, since it's definitely the first job from the active military, we're not charging anything for this, and thank you for your service. All right, let's get to it. We're gonna use a new version of Rework Pro, which actually you can set the hourly rate in Rework Pro and start the timer whenever you want, and you can pause it as well, and it'll calculate how much you are charging for this repair. So obviously this is not going to be what I'm going to charge for this repair, but just as a reference, right? What I would normally charge if I or maybe because I still charge only $50 for this, right? For the socket replacement, no guarantee, no testing, no nothing like that. But if it was like a full repair, that's probably what I would have charged, like $75 an hour, something like that, which is still not huge, right? Some shops charge a lot more an hour than that. Alrighty, let's get to it.
Keep
Alrighty, we're gonna call it a partial success because let me show you. As you can see, the socket melted a little bit over here. It's not a huge melting, right? It's only surface melting, and I don't think that will cause any issues, but I don't like to see sockets melted. Alignment looks good. Looks like it was before, I think. I took a picture. I'm actually not sure about the alignment. Is it more shifted? Oh, see, I don't know. I'm not sure because different sockets can have different margins. But I don't know. Looking at it now, it looks aligned. Now, it didn't want to let loose, but here's the problem I'm struggling with still. I used to, for the longest time, I used 210 on the bed, at the bottom, not on the bed, at the bottom of the board, 210 degrees. 210 degrees, the solder at the bottom is almost molten, it's almost dripping, which sometimes results in cups just falling on my heater, especially if you're just tap it at the top or something like that. Second, the board, well, deforms a lot more significantly at 210. Then the, what do you call it? The thermocouple that touches this side of the board, sometimes it'll move, and it'll move some capacitors at the bottom of the board. This one doesn't have many of them, but still, it's a risk. So I decided to work closer to like 185. And that's been working on some boards, not on the others. So 210 is a lot better, but it carries some risks. So I did it at 185 at the bottom, and after the procedure, I checked this corner over here, and it was completely lifting. Like this entire corner, this entire quarter of the socket was not soldered on at all. Now I used very little flux, and I didn't add any flux afterwards. It works better when you add flux right before the reflow. It definitely works better. It holds much stronger and it floats, but then there's further risks of making bridges and stuff like that. So I'm still kind of adjusting my procedure. But so this one will call partial success, or we can call it failure because of this melting. But the socket, I think the socket should work. It is nice and stable. I checked all the corners and everything. It should be good. So we'll see. We will or we won't. Because I don't know if the customer is going to let me know. Not everybody does. And I don't mind. It's, you know, your call. In my next, because I have like 7 more to do, I will go back to putting 210 at the bottom. On this one, since it didn't want to let loose initially, right? The socket wouldn't let loose until 230. And resoldering the same thing. I used 230, that's why we have melting, because we can't control the temperature that precisely. Then the lengthy process means I need to turn on the top heater, the top fan, which causes more airflow and, you know, different process. Anyways, we're gonna stop here. The board is clean. Now it just needs to dry, and we're gonna be sending it back to Japan. Thank you guys very much for watching. I do appreciate you, and I shall see you in the next one.